Hello guys, welcome back to the channel. So we are again solving our daily Leetcode question. Question number is 576 out of boundary paths. So there is M and X grid with the ball. The ball is initially at the position start row and start column. You are allowed to move the ball to one of the 4 adjacent cells in the grid. You can move it at most max moves to the ball. So let's time it, right? So given them 5 integers m and n, max move, start row, start column, return the number of the paths to move the ball out of grid. So okay, outbound constraint, and then there is this answer can be a very large because there will be a lot many possibilities. So we will return modulo just in case. Okay. So if you look at examples, so there is this 2x2 grid, and then ball is in start row 0 and start column 0, so on top left. So as you can see on the first, it moves 1 and it goes out of grid, and similarly in this side, and then max move is only 2, so we can at most make only 2 moves, and we want to make sure the ball is out of grid, right? So it will be our stopping condition. So if we are doing it recursively, and yeah, so give at any given point there are so many solutions. Like if this grid increases to 3 across 3, then this number will also increase depending upon the max move supplied, right? But we, as a software engineer, we need to account in the worst case scenario. So in this case, if we are making or using a path, for instance, this is the path, right? We are also making this path in this example, like here also. So what the best case scenario would be to use LRU cache. That way we store the previous results. And talking about storing previous results, we can use dynamic programming. Okay, first we will be looking at LRU cache, and we will make this because we want to cache our results, and we'll be using dp function as we talked about, and then we will be returning the dp and the starting point of it. So start row and then start column, and this needs to be maximum, so we want to just copy here and this. Let's do it like 1 2 3 4 5 6 7 8 9. Okay, that's a big number. And okay, so let's define our dp function then. This is our starting row and column, so x and y, and then we will supply steps as a stopping condition. So we will not make it mandatory, but we will take max move here. Now first condition is we are allowed to move in any 4 direction adjacent cells, so we cannot move in a diagonal way, and return the number of paths move out of grid. So we will define out of grid method, right? Out of grid. So how we will do that? We will just check in, like if the x is in the range of m, right, or y is range of n. If both are any of them are not, then they are out of bound, so we will increase our count. And if there are no steps left, so technically 0, then we will just return 0. So that means we cannot make more moves from here, and we need to return 0. So what we will do is we need an answer. This is just a variable that we will output for this dp, and then this is like a new dx and new dy. Because we are want to go in 4 different directions, we are defining this new x and new y. So answer would be 0 at first. Dx can be 1 and then 0, and there's a method that we can move our ball. So we will be going in south, then east, and then north, and then west. Okay, so to do that, we will just, this is the method I learned recently to move any elements in this type of question in this circular manner, anti-clockwise. So first we would just call this dp function. In this dp function, what we need x plus this new dx, then y plus new dy, and every time we do that, we will deduct from steps. Okay, right. And then to make use of our circular manner output, we would do this and then dx. I'm pretty sure this is the formula, and now here we will return our answer. And I think that's about it. Let's run it. Yep, there you have it. So we solved it under 10 minutes, and that's only because I know the concept of LRU cache and about this direction that I learned recently. And we also want to make sure the maximum is this modulo. So let's submit it and see. Okay, I think I added one more 0. Is that it? Yep, so I added one more 0 there. So yeah, there you have it. So see you guys tomorrow. Please make sure to hit the like and comment down below. See you in the next one.